After cholesterol is digested, it travels to the human skin where it is then turned into cholecalciferol. Cholecalciferol then travels to the liver where it is then converted into calcidiol. After cholecalciferol is converted into calcidiol, PTH binders in the kidney upregulate certain enzymes along a certain gene of DNA, which allows calcidiol to be converted into vitamin D. In response to hypocalcemia, the parathyroid gland releases PTH, which binds to 3 places. First, the osteoblast, which is downregulated, and second, the osteoclast, which is upregulated. This automatically introduces more calcium into the bloodstream. Third place it binds to is the kidney. PTH binds to the kidney, which allows calcidiol to be converted into vitamin D, as explained in the last video. Now, vitamin D then attaches to the vitamin D binding protein, which allows it to travel through the bloodstream, where then vitamin D attaches to the vitamin D receptor and forms a hormone receptor complex. This hormone receptor complex binds to DNA, which then creates a cal-binding channel, which allows calcium to be digested in, thus releasing more calcium into the body. Okay, so now we're going to talk about the mechanisms as to how steroids and non-steroid hormones work. So first, let's start off on steroids. Steroids take a transport protein through the bloodstream due to its insolubility in liquids. Then it just safely passes through the membrane, a cell membrane, and attaches to a receptor that forms a hormone receptor complex. After the hormone receptor complex is formed, it up or down regulates certain proteins. Now let's talk about non-steroids. Non-steroids can safely pass through the bloodstream without any trouble. However, they can't pass through the cell membrane, so it has to bind to a receptor, and then it can travel through the membrane and into the cell. So now we'll talk about the release of hormones associated with puberty, and for the first half of this video, it's the same from males and females, but then I'll tell you when it differentiates. So the hypothalamus secretes gonadotropin-releasing hormones, GnRH, as represented here. It releases it from the hypothalamus, and it travels to the pituitary gland. GnRH into the pituitary gland, where then luteinizing hormone is released. And here's where it starts to differentiate between males and females. For males, it'll travel to the testicles, but more specifically, receptors located in Leydig cells. For females, luteinizing hormone travels to the ovaries and the granulosa receptors along the granulosa cells that are located there. For males, it'll cause testosterone release. For females, estrogen release.